Okay, lesson 3 is rate of change, which is related to the previous lesson on slope. So here, let's review. On slope, we use the formula y2 minus y1 divided by x2 minus x1, which is rise over run. So here, let's investigate the relationship between slope and rate. So Robin is preparing to make taquitos for supper. She preheats the oven to 450 degrees Fahrenheit. The graph represents the temperature of an oven as it warms up. So here's our graph. So notice we have time and we have oven temperature. Okay, so our independent variable is time and our dependent is oven. So 0, 50, remember this is the axis and y is the vertical axis. And so on our point x and y, we know that x has to do with time. So we have 0 minutes and y is our temperature in Fahrenheit, so 50 degrees Fahrenheit. So at 0 minutes, the oven is 50 degrees Fahrenheit. So basically room temperature. So there's the first point. It says, what does the point 5 and 400 on the graph represent? So again, remember x comma y, x is minutes, so 5 minutes. So at 5 minutes, the oven temperature is, and so y is our Fahrenheit, so 400 degrees Fahrenheit, our temperature. So basically it took 5 minutes for the oven to reach 400 degrees Fahrenheit. Calculate the slope of the line joining these 2 points. So there's a few ways we can do this. Let's use the formula, our slope formula above. So we have, I'm going to call this first point x1, y1, 0, 50, and point 2, x2, y2. And we can just go ahead and use our formula. So remember our slope formula, y2 minus y1, so rise over run. So the difference of the y's divided by the difference of the x's. So difference of our y's, we're going to have, so we want to figure out, okay, what's that rise here? What's this change of y? And our change of y we're going to get from 400 minus 50, y2 minus y1. And that will give us 350, the difference. And our change of x will be x2 minus x1, so 5 minus 0. So we get 350 over 5, which makes sense. The oven changed in temperature 350 degrees over 5 minutes. We divide that, we get 70. And so if I asked you, okay, well, what does that represent? We need to look at our units. What was our rise? So our rise was degrees Fahrenheit, and our run was in minutes. And so 70 degrees Fahrenheit per minute. So the slope represents a rate of change in temperature divided by a change of time. So what units are used to represent this rate of change? And that unit would be degrees Fahrenheit per minute, because our rise is degrees Fahrenheit and our run is minutes. Just make that like a degree. There you go. Complete the following statement. The temperature is it increasing or decreasing? And so here we have an increasing, it's rising to the right at a rate of 70 degrees Fahrenheit per minute. Okay, part 2. So water is leaking out of the bottom of a barrel at a constant rate. At 2 minutes, the water level is 62 centimeters, and after 7 minutes, the water level is 22. On the grid, plot the order pairs time, comma, water. So they're saying x is time and y is water. And actually, time is always going to be the independent variable. It's always going to be on the x-axis. So the x-axis and our y-axis is going to be water level. So we have 2 points to plot. Our first point is after 2 minutes, the water level is 62 centimeters. So we have 2 comma 62. And the other one we want to plot is after 7 minutes, the water is 22. So 7 and 22. So we want to plot those on our graph. So our x's, we know we have to go up to 7. So 1, 2, 3, 4, 5, 6, 7. Our 7 and our 2. And we need to go up to 60 on the, so I'll go up by 10s. 10, 20, 30, 40, 50, 60. And it's going to be a little bit of an estimate. And our horizontal, 1, 2, 3, 4, 5, 6. Okay, so our first point at 2 minutes, we're at 62 centimeters. And at 7 minutes, we want to be at 22. So there's our 2 points. So I'm going to put those on there. It's really helpful to label your points and put them on the graph so that if we have to calculate slope, they're ready to go. So 2 and 62 and 7 and 22. And here, they tell us that it's leaking at a constant rate. So we're going to connect those lines. We know that it's uniformly emptying, right? It's at a constant rate, it's emptying. So it is a straight line. Okay, so calculate the slope. So again, our formula for slope, y2 minus y1 over x2 minus x1. We want the difference of the y's, which will give us our rise, over a difference of our run. So I'm going to label my points on the side here. So I'll call x1, y1, the 2 and 62, and 7 and 22, x2, y2. Remember, it doesn't matter which one you call your 1s and 2s, but every point always goes x comma y. Okay, so plugging it in, y2, I have my y2 is 22, minus y1 is 62, divided by x2 is 7, minus x1 is 2. So 2 minus 62 is negative 40 over 7 minus 2 is 5. And we divide negative 40 divided by 5 is negative 8. Now, it would be helpful here to do, okay, what does that negative 8 mean? Let's put our units in. So on the rise, the vertical axis here, the y, was water level in centimeters. In centimeters. So I'm just going to add that centimeters to the negative 40. And then the horizontal, which is our change of x's, was time. And that was in minutes. So that negative 8 should be centimeters per minute. And why is it negative? Well, let's think about the question. Water is leaking out of the bottom of the barrel. So our height, the water level, is decreasing. So notice the slope remains at a rate, represents a rate of change. A change in water level divided by a change in time. What units are used to represent this change? We just talked about that. Centimeters per minute. Explain the following. The water level is changing at a rate of negative 8 centimeters per minute, and the water level is decreasing at. So if we use a decreasing, we don't have to put that negative in. 8 centimeters per minute. Okay, so there you go. So that's our rate of change here is the same as our slope. If you use words like decreasing, that takes away the negative. If we're just talking about the rate of change, then we put in the negative. Okay, so big idea here. The big idea is slope is the same as rate of change. Okay, moving on. Oh, one too many. So slope is rate of change, and that's what we just said. Slope represents rate of change. It's a big idea here. So if I ask for the rate of change, really what you're looking for is the slope. A couple other points to look at. A positive slope equals a positive rate of change, and that, remember, is rising to the right. And a negative slope would be a negative rate of change. Another thing to remember is if we're dealing with a distance time graph, so for a distance time graph, so distance time, okay, the slope of a line segment joining 2 points represents the average speed. So as long as it's a straight line, that slope equals the average speed. Why? Well, if distance usually is meters or kilometers, time in seconds or hours, our slope, change of y over change of x, will be meters per second, because those are our units. And so it's going to represent, as long as it's a straight line, our average speed. So let's look at a question with a distance time graph. Dave entered his car in a long distance car race. He traveled the first 150 kilometers in 2 hours. So you know that's going to be a point. right? They go together. After 6 hours, he traveled 650 kilometers. Plot the ordered pair to represent this information. Explain why 0, 0 is included as an ordered pair in this scenario. Something to remember is whenever we graph with time, time is always on the horizontal axis. So time in hours is going to go on the horizontal, and distance would then go on the vertical, and it's in kilometers. We know that he's going to be driving for up to at least 6 hours. Sometimes I like to look ahead and see, okay, in future questions, am I going to need more time? And we won't. So we're going to just want to graph to at least 6 hours. So I think this works out nicely. 1, 2, 3, 4, 5, 6. And perhaps we should go by 50s. We have to go at least a distance of 600. So every small one is 50. So this is 100. Every second is 200, 100 distance. So 100, 200, 3, 4, 5, and 6. Now it wants us to plot these points, plus 0, 0, and also explain why 0, 0 is a point. So I'm going to plot 0, 0 start, and we'll explain after. We also have 2 and 150, as well as 6 and 650. So we need to get up to 650, right up there. Okay, and we're just gonna connect those. So I'm gonna use, I'll just draw it the best I can. So 1 and 2, just like that. I'm gonna label our points. So we have 0, 0. We have 2 and 150, as well as 6 and 650. Okay. So explain why 0, 0 is included. We want to use words whenever we see explain. And if we have a distance time graph, let's remember first 0 be 0 x is hours, so 0 hours, 0 kilometers. Why does it make sense that we went 0 kilometers in 0 hours? Well, when we just start, we haven't moved yet. So after 0 hours, he has traveled 0 kilometers. He has traveled 0 kilometers. Okay. Calculate Dave's average speed between 2 hours and 6 hours. So I'm going to label my points as usual, x1, y1, x2, y2. And we'll use our slope formula. So the slope formula is y2 minus y1 over x2 minus x1, and plug it in. So x2 is 650 minus y1 is 150 divided by x2, 6 minus x1, which is 2. And we want to subtract those. Remember, if you were to plug this into your calculator, you would need to make sure you put brackets around your numerator and denominator if you want to do it all at once. So 650 minus 150, bracket, divided by bracket, 6 minus 2, and then 125. Now we want to include those units, so let's just add them in. What was our vertical? Remember your y's on top, and vertical is distance in kilometers, and horizontal is on the denominator, which was in hours. So that's kilometers per hour. So the rate of change was 125 kilometers per hour. And it asks, is this considered a rate of change? And yes, it is, because the slope is the rate of change. So the rate of change is 125 kilometers per hour. Yes, this was a rate of change. By looking at the grid and without doing any calculations, how can we tell that the average speed during the first 2 hours was less than the average sleep during the next 4? And remember we talked about slope, and slope is the steepness of a graph, right? And so the greater the slope and the greater the steepness, the greater the rate of change. And so we can look at the graph and say, hey, the first 2 hours wasn't as steep, therefore his rate of change is not going to be greater. And so let's say the last 4 hours, the line is steeper, or the slope is steeper. So the rate of change will be greater, because slope is rate of change. Okay. The graph shown represents the amount of fuel in Dave's gas tank as a function of the distance traveled during a portion of the race where he drove at a constant speed. Calculate the slope of the line. So again, we're just practicing using our slope formula, x1, y1, x2, y2. Write out our formula. It's always a good habit to write out that formula, because then you'll know you're substituting it correctly. So we start with y2, and y2 is 40. So we have 40 minus y1, and y1 is 50, divided by x2, and our x2 is 120. Subtract x1, and x1 is 20. So if we just do this in our head, we have 40 minus 50, which is negative 10, divided by 120 minus 20 is 100. And so if we either reduce it or just divide it. If we just divide, we get negative 0.1. Now we want to get units here. So notice how number of liters was the y. So the number of liters in the fuel tank, and distance was on our x. So our liters per kilometer is that unit. I notice it's a negative rate of change, so it's decreasing. So we'll complete the following statement. The amount of fuel in the tank is, because it's a negative rate of change, it's decreasing. The rate of change of the fuel is negative 0.1 liters per kilometer, or you could say the amount of the fuel is decreasing at a rate of 0.1 liters per kilometer. Okay? And that's it for this lesson. So questions 1 through 9 for practice.